All right, slide 9. We've just covered two other derived units of measure. We know that area, that's going to have units of length squared. So area could be measured in inches squared. You could have that. You could have miles squared, square miles. Tend to not going to use those units in this course. You're more going to see meters squared or centimeters squared. We also talked about volume. You could have inches cubed. You could have miles cubed. In our course, we're going to tend to talk about things in terms of meters cubed or centimeters cubed. There's also this unit of liquid volume that we use, that's the liter. And we abbreviate that with a capital L. And of course, we can stick prefixes in front of this. You know, you can have a milliliter, you could have a centiliter, or just a plain liter, and so forth. Two other derived units of measure I'm going to introduce, and there'll be more as we go throughout the course. But two other derived units of measure I'd like to talk about are speed and density. Speed, well, that's going to be your distance that you travel in a certain amount of time. So you take the distance that you travel and you divide that by the time it took you to travel that distance. So what are some appropriate units of speed? Think about it. Well, there's a lot of different ones. I can measure distance in meters. And I can measure time in seconds. And because to measure speed, I take my distance and divide it by time, I do the same thing with the units. I take my distance and I divide it by a unit of time. So that we call that a meter per second. That would be the unit here. We also write this in a slightly different way that you should recognize. You may remember from algebra class that you can write 1 divided by some variable a. We can write that as a to the minus 1. And I use this a lot because it simplifies things later on. So I can also write this unit here like this. Do you see the agreement there? A meter per second is the same thing as a meter times a second to the minus 1. Those are identical, and you should get used to using things this way. We can also talk about distance in meters per hour, which I could write like this. We could do inches per century. There's a whole host of different units that are associated with speed. We are going to use meters per second in this course to talk about speed. Density is an extremely important concept in science. It helps describe a lot of different phenomena that's observed. We'll do some experiments in class to explore density in a bit more detail. But density is defined by how much mass is contained in a certain volume. So to calculate the density of a substance, you take the mass of that substance and you divide it by the space that that substance is taken up. So what are some appropriate units for density? Well, if we think about it, I'm going to take some mass units and divide those by some volume units. So I know mass is measured in grams, and volume can be measured in milliliters. So an appropriate unit for density is gram per milliliter, which I could also write like this. And you'll see this. It could be kilogram per centimeter cubed. It could be pounds per inches cubed. Pounds is a unit of mass. Could be written like that. Of course, not in this class. We're going to tend to use gram per milliliter and gram per centimeter cubed in this course. Look at that. Those are both density units. In one case, I have gram per milliliter and gram per centimeter cubed. These are both units of density because a milliliter is a unit of volume and a centimeter cubed is also a unit of volume. Let's do a density problem. Oh, let's say a rock has a mass of 247 grams and a volume of 11 milliliters. What's its density? It's a very simple calculation. If we use the equation, the density is 247. Well, density is mass divided by volume. Let me do that first, of course. And then we're just going to go ahead and plug in the mass, which is 247 grams. And we're going to divide that by 11 milliliters. The units would be gram divided by milliliters. This is half the answer, folks. Right there is half the answer. If you only put in the numbers, you're half right. Or half wrong, depending on how you're going to look at it. In terms of how you'd be graded on an exam, it'd be half right. So keep that in mind. 247 divided by 11. You're getting... That's not a rock. Holy cow, that's a pretty high density there. 22.45 grams per mil. Does that have to be a metal? That's about the density of osmium. What's he saying there? Well, see, we happen to know with pure substances, we happen to know that if you take a particular pure substance like gold or silver or copper, and it's fairly pure, because nothing's really pure, but if things are relatively pure, and we measure the density of those things, that those densities always come out the same. The density of zinc, for example, is always zinc 7.13 grams per mil. The density of water, it varies a little bit with temperature, so you got to be careful of that with water. Water expands as it warms, and because water expands as it warms, let's think about that. Water expands as it warms. So let's say I have 1 gram of water. Well, let me tell you this first. Water generally has a density. You should memorize this. The density of water is 1 gram per milliliter. This is an estimation. I've only written 2 digits here, so I haven't put like 1.0 whatever, or 0.99 whatever. But to a really good approximation, and in this course to a lot of the things that we're going to use, we can think about the density of water as being equal to 1 gram per milliliter. And that's kind of helpful because it tells me if I have 1,000 milliliters of water, if I have a liter of water, that's the same thing as 1,000 mils. If I have 1,000 milliliters of water, I know how many grams I have. It's very convenient, just right away. If I've got a gram, I've got a milliliter. If I've got 10 grams, I've got 10 milliliters. We can do that with water. Can't do that with other substances because other substances have different densities. So zinc, for example, like I mentioned before, has, if it's pure, its density is roughly going to be this. Copper. That has a density, if I remember correctly, is it 8.9? I think it's 8.96 grams per mil. Hold on, let me make sure that's right. Hey Siri, what's the density of copper?
The density of copper is about 8.94 grams per
I was off a little bit. 8.94. Gold. 19.3 grams per mil. So there are many metals that you can, in a sense, you can gain evidence that you have that particular metal by measuring the density of that metal. If I have a yellow metal that's nice and shiny, conducts electricity pretty well, and it's got a density of 19.3 grams per mil, it's a decent chance that that metal's going to be gold.